Thanks for the privilege and welcome again to another class as we continue with our subtopics in elementary set theory. In this class, we are going to consider first of all null sets. Null sets. Now, what is a null set? Sometimes these null sets are also called empty sets. They are also called empty sets. In some books, you can see it as void sets. So, irrespective of the case, know that they are referring to the same thing. Now, a null set is a set that does not have any element. A null set is a set that does not contain any element. Some may say, how is it that a set will not contain anything? Yes, there is the possibility that there are some collections that are empty. Example of such sets are, say, people living on Earth who are above 2,000 years. Example. People, a set of people. Let's say a set of people. People living on Earth. Living on Earth that are above 2,000 years, 2,000 of age, 2,000 of age. You can see that there is no human being on Earth that lives above 2,000. So such a collection is empty. A is therefore empty. Now, when writing it, either you write it like this, or you say A is, we use a sign for it called phi. When you see this sign, we are referring to the set as being void or empty or a null set. There are a lot of examples that we can show in respect of this as a null set. You can say, let's consider another set, a set, say B, where its elements are, X, let's say X is such that X is a natural number. Natural number. Where X is, you see, natural number, where 1 is less than equal to X, less than equal to 2. This collection is also empty because the set of natural numbers they ranges from 1, 2, 3, on we go. And if X is less than 1, and at the same time less than 2, meaning X is within this interval, and we are talking about numbers 1 point something, 1 point something, and they are not whole numbers, they are not natural numbers. These are sets of natural numbers. So in a way, in other words, we can say this set is also a good example of an empty set. And we have a couple of examples. You can say a set where its collection, the people living on Earth that are moving on their heads. Everybody move on their foot and not head. Such a set is also empty. So, in other words, we are saying that there are some sets that are into consideration that can also be seen as a null set, or you say empty set. Now, in some books, there are some cases where some people make mistake in using some words. These null sets, some do call it zero sets. Zero sets. This is not a zero set. There is a difference between a zero set and empty set. A set is called a zero set. Zero set if its elements is 0. The only element it has is 0. In such a case, we say that set is called a zero set. A collection where its elements, say A, let A be a set, where its collection is 0. This kind of set is called zero set, and not this one. This one is called empty set, and this one is called zero set. How do you know that? If you determine the cardinality of a null set is 0, but nothing is in the number of elements in a null set, the cardinality of A in this case, let's say this one is B. The cardinality of A in this case is 0 because there is no set in it, and this is not called zero set. While the cardinality of a zero set, where we have the cardinality of a zero set, say B, is equal to 1 because we have one element in it. So even this one shows that these two sets are two different kinds of sets. So a set is called a zero set if we have 0 as the only element in it, while we call it a null set if there is no element. It's a collection of nothing. Nothing is in it. Such sets are called null sets. Now this one is pretty simple and easy. Next, I want us to consider subsets of a set. The subset of a set. Subset of a set. Subset of a set. Now, it is natural that in a particular collection, if we are considering two sets of collections, that's two sets, there is a possibility that one is a sub of the other. Sub in the sense that the elements in one are all contained in the other one. Like if we consider the set of natural numbers, let A be the set of natural numbers. So we have 1, 2, 3, 4, on we go, set of natural numbers. And let's say let B again be a set of all even positive numbers. Even positive numbers. So 2, 4, 6, on we go. So you can see that this set B is contained in set A. All the elements in set in set B can be found in set A. So this kind of presentation is what we refer to as a subset of the other. So in this case here, B is a subset of the other. But we are going to discuss these subsets of a set in terms of proper subsets and improper subsets. Proper subsets and improper subsets. Now, first of all, a proper subset. Now, we say a particular, given two sets, say A and B, we are saying B is a proper subset of A if and only if all the elements in B are contained in A. And there are also some elements that are left which are not contained in B. Like in this case, how do I do it? Let me repeat again. I said two sets are said. given two sets, we are saying that given two sets, say A and B, we are saying that B is a proper subset of A if and only if all the elements in B are contained in A, and also there are elements in A which are not contained in B. In such a case, you say B is a proper subset of A. All the elements in B are contained in A, and there are also some elements in A which are not in B. In such a case, we say that B is a proper subset of A. Like this is another good example of a proper subset. Now let's consider another one, say a set E, where its elements are set of names of animals, say cats, rats, dog, and dog. Let's consider another set, say F, where its elements are cats, rats. Now, given these two sets, we are saying that F is a proper subset of E because all the elements in F are contained in E, whereas there are some elements in E that are not in F. So you can see that the cat is here, rat is here, rat is here. So it's a subset, but it's proper because there is an element here that is not contained in this one. So this kind of representation we say is called a proper subset, when one is fully contained in the other, and there are also elements in the other that are not contained in the former. Now, the next that I want to talk about is improper subset. Improper subset. We say, given two sets A and B, we are saying that A is an improper subset of B if and only if all the elements in A are all contained in B, and as well all the elements in B are also contained in A. How do I mean? Let's give example. Let's consider a set, say Q, where its elements are say A, B, C, and D. Let's consider another one, say P, set P, where its elements are B, C, D, and A. Now, we are saying that these two sets are improper subsets of each other. They are improper subsets of each other. They are improper subsets of each other. Improper in the sense that all the elements in Q are contained in A, and also all the elements in P and all the elements in P are also contained. So you say Q is an improper subset of P, and vice versa because they are all the same. So you say P is also an improper subset of Q because they all contain each other and all of them are exact. So you say they are improper subset of each other. Let's consider a set again. So they are improper subset of each other. So but let me further by saying something. If you study these two sets carefully, Q and P, you can see that all the elements that are in the cardinality of set Q is 4. And the cardinality of set P is also 4. Though the placements, the position with which the elements are placed differs, but we say the manner in which the elements are arranged doesn't really matter. The order with which they are arranged doesn't really matter. Now, being the fact that, despite the fact that the cardinalities are the same, we can also see that set P and set Q also contain the same type of elements. So in our previous class when we were talking about equality of set, we said two sets are said to be equal if they have the same cardinality and the same time if they have the same type of set. So this one, we are saying that these two sets are also equal. So as we are talking about the subsets, the improper subsets of set, we can also further say that two sets are said to be equal, because in this case, because it also meets the criteria of equality. So we can say two sets are said to be equal if they are improper subsets of each other. We are saying that two sets are said to be equal if they are improper subsets of each other. Two sets are said to be equal if they are improper subsets of each other. Now, if a given in a given statement, let's say, let's consider a set A where its elements are the 36 states. 36 states of the Federation, in bracket Nigeria. Let's consider this as a set. Let's consider another set, say B, where its elements are the crude oil producing states in Nigeria. What kind of set is this? You can see that, or I will say which one is a proper subset or improper subset of each other. In this case, you can see that we are not talking about improper here, because set B does not contain all the elements in set A, but rather set B is fully contained in A. So we say that B is a subset of A. B is a subset of A. Now, this kind of statement, you can write it in another form by saying A is a super subset of B. A is a super subset, meaning A contains all the elements in B. A is a super subset. Super subset. Super subset is a super subset. This one is subset, while this one is super subset. So you can write it this way, or these two things means the same thing. This one is a subset of this, that B is contained in A. While this one, A is a super subset, means A contains all the elements in B. Now this, we can also consider, say, another example. Let's consider another example. Let's consider another example. Consider a set, say Q, where its elements are A, B, and E. Another one, say P, where its elements are A, B, E, A, B, C, and D. A, B, C, and D. Now, in this one, which one is a proper subset or improper subset of each other? You can see that Q, in terms of cardinality, Q has 3, while the other one has 4. So, in terms of cardinality, they are not the same. But in terms of the elements, you can see that we have B here, A here, A here, B here, B here. But here we have E, and E is not contained here. While whereas in this one we have C and D, which are not also contained. So it's not, they are not proper subset or improper subset of each other. They are not proper subset or improper subset. So in this one we say Q in terms of proper and improper subset, we can still say that Q is not a proper subset of P. And in like manner, they are not also, Q is not also an improper subset of P. It's not, so you negate it. So why I choose to bring this is that if we are talking in favor, we can also talk in the negative way. So this is to negate that it's not. When the something is not, you use this bar to cross it. So this one gives us a good clue of what we have. Now I also wish to, let's do something. I also wish to tell us that the null set, which we have studied earlier, is a subset of every set. The null set is a subset of every set. And in this other one, where we were talking about improper subset, let's assume we have this now, E here. We say that Q is an improper subset of P, and likewise P is an improper subset of Q in this case. So in this case we are saying that these things are subsets of each other. So in a way you can say a set is a subset of itself. A set is a subset of itself. Note that we have stated that the null set is a subset of every set. And in like manner, a set based on this, we can say a set is a subset of itself. Now before I conclude, let's consider one example. Let's consider one example. Given that B is equal to A, B, D, and G, find all the possible subsets of B, and also identify the proper and improper subsets, and also identify the proper and improper subsets. Now, with this is a good question that we can do business with, that will answer most of the things that we have talked about. Now, we are talking about subsets, and for it to be a subset, meaning that either all the elements that are in that element are there, or all the elements that are in that element are there, or the sub is contained in the element. Now, in this very example, we have B as a set, A, B, D, and G. Now, the subset that we are to look at, the collection that we are to look at is 1. We said the phi, the empty set, the null set is a subset of every set. So we say this is a subset of itself. Then the individual collections, we can say A is a subset of this one. If this is a set, you can see that this is contained in this, is a subset. We can see that B is also a subset. D is also a subset. G is also a subset of this. That's not only that, we can combine two. A and B is also a subset of this set. A and D are also subsets of this. A and G are also subsets. Then you can see that B and D are also subsets. B and G are also subsets. D and G are also subsets. Of this. You can see they are all contained in this. Then you can further say A, B, and D are also subsets. They are all contained there. A, B, and G is also a subset. A, D, and G is also a subset. We have B, D, and G is also a subset. And lastly, we said every set is a subset of itself. So you can say A, B, D, G is a subset. So you can see that what we have listed here, these are all subsets of this particular set. Now, the second question is identify the proper and the improper subset. Now, for it to be a proper subset, we said all the elements must be contained in the other, all the elements, and there must be some elements left in the other one which are not contained in the other one. So in this one, you can see that the 5 is a subset of this one. These ones are there which is not contained in this. This is there, these are not contained in this. So this one is also a proper subset, this one is a proper subset, this one is a proper subset, this is a proper subset, proper, except this. It's only that, the last one, that is not among the collection of all these ones are satisfy the criteria for that of a proper subset. Whereas this last one is among that of improper subset. So you can see, lastly, conclusively, we are saying that for a set to be a subset of the other, with a proper subset of the other, we are saying that the proper subset, the subset must be contained, all the elements in the subset must be contained in the other, in the bigger set. And there must be some elements in the bigger that will not be in the smaller. And in like manner, if we want to talk about that of improper subset, we are saying that all the elements that are in A, say two sets, considering two sets A and B, all the elements in A must be contained in B, and in like manner, all the elements in B must also be in this. And we concluded by saying that a set is said to be equal if they are improper subsets of each other. Thanks and God bless as we look forward to having other classes.